Hello and welcome to this tutorial. In this tutorial, I'm going to answer a more concept question, which is a 2015 question from a pure chemistry ECZ. So let's dive into it. So a sample of iron filings had partly rusted upon being left under damp conditions. 3.5 grams of the iron filings were added to 50 cubic centimeters of aqueous copper 2 sulfate. All the copper in copper 2 sulfate was displaced according to the equation. So the first question is write the ionic equation. So to write the ionic equation, it's simple. The first thing I have to do is dissociate the compounds in aqueous state. So Cu is dissociated like that. Copper ions, sulfate ions. Nothing happens to the ion because it's not in aqueous state. Then nothing happens to the copper because it's in solid state. Then this will dissociate to iron 2, then SO4 to negative. So at this point, you just identify the spectator ions, you cancel them, then the final becomes this. Cu solid, then Fe2 positive, aqueous. So that's the final answer. Then we are given 3.2 grams of copper as what was produced. So to find the mass of iron in this case, it's very simple. Using the law of conservation of mass, provided the equation is balanced, you just get iron and you get copper. Find their relative molecular masses. This will be 56, this will be 64. Then the mass given for copper is 3.2 grams. Then there you say X. So therefore your X becomes 3.2 grams by 56 divided by 64. Therefore in this case, your mass of iron, when you punch on the calculator, is supposed to be 2.8 grams of iron. The next question is the percentage by mass of rust in the iron filing samples. So if I know the mass of iron, what I can do is the mass of the sample which was given is here for iron filings was 3.5 grams. So how can I go about it? Okay, there are two ways. The first thing is I can find the percentage by mass of iron, which is divided by the sample times 100%. So this is the percentage by mass of iron. So this, when I do the math, gives me 80%. So to find the percentage by mass of rust, in this case, I can just say 100% minus 80%, and this will give me 20%. Or the other way is, the other option is, I can get, let me use a different marker. The other option is I can get the 3.5 grams, I subtract the 2.8 grams, then divided by 3.5 grams times 100%. I'm sure this will still give me that 80%. Then the last question is asking me to find the concentration of copper 2 sulfate in moles per cubic decimeters. So when we go back to the question again, we're going to realize that the iron was put in 50 cubic centimeters of aqueous copper 2 sulfate. So how do we go about it. So the first thing we can do is, now that we know the mass of copper which was given here, I can find the number of moles of copper. So I can say number of moles of copper is going to be mass divided by molar mass. The mass given is 3.2 grams. What is the molar mass of copper? 64 grams per mole. This gives me 0.05 moles. So if I know the number of moles of copper, then looking at the equation, they both reacted in the ratio of 1 to 1. When I look at the ratio of copper 2 sulfate and copper, they both reacted in the ratio of 1 to 1. So if this has a number of moles as 0.05, even there the number of moles of copper 2 sulfate will be 0.05 moles. So if I know the number of moles, then what will be the concentration? So concentration is number of moles divided by volume. The number of moles is 0.05 moles. What is the volume? So the volume that was given when we go back to the question is here 50, but we are required to convert it to cubic decimeters. So 50 divided by 1000 to convert it is going to be 0.05 cubic decimeters. Then when we do the math, that becomes 1.0 mole per cubic decimeter cubic. Okay, for any questions, clarification, please slot them in the comment section. See you in the next video.